So in this video, we're going to be working with parallel and perpendicular lines. For that, I'm going to go over a couple of theorems. The first one is the book that I use as reference for this presentation. It says theorem 3a, but that could change, right? But it says that if two lines are parallel to the same line, then they are parallel to each other. So if line L is parallel to M and line M is parallel to N, then L is parallel to N. The same way, if in a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So you can see right here, line N is perpendicular to M, and P is perpendicular to M. So that means that line N and P are parallel to each other. My next one, perpendicular transversal theorem. In a plane, if one line is perpendicular to one of two parallel lines, then it's perpendicular to the other one. So if line T is perpendicular to, if K is parallel to L, so if K is parallel to L and T is parallel to K, that means that T perpendicular to K, that means that T is perpendicular to L. And the last one that we postulate that we're going to use in this lesson is that says through a point not on a line, there's one and only one parallel line to the given line. Okay, as you can see right there. So let's see this information right here. It says that BC, line BC is parallel to, let's mark this one right here, is parallel to the F right here. And DF is parallel to GH right there. What is the relationship between BC and DH? So that means that in this case, BC, segment BC is also parallel to GH. Why? Because if that line, BC is parallel to EF and EF is parallel to GH, then those two lines have to be also parallel. So BK is parallel to EL. BK, let's use another color. BK is parallel to EL. EL right here. DH is perpendicular to BK. So if we continue this line right here, these two lines are perpendicular, right? So it's asking me what is the relationship between GH and EL. So in this case, GH has to be perpendicular to HL. So you can see right here, right? Because that slope or that line is not gonna change. It's gonna continue the same. So that one, this line right here, they have to be also perpendicular. This one says draw a diagram that meets the criteria below, then describe how all lines are related to each other, right? So we're gonna draw one that is this one. So let's start by saying that QR and Q is parallel to R. Is parallel to R right there, right? T and Q are parallel also. So T and Q are parallel to each other. R and S are perpendicular lines. So R is perpendicular. It's a perpendicular line. Use that other color. Right? And U and T are perpendicular. So U and T are perpendicular. U, right? So now we can see right here that line T is parallel with line Q with line R, right? We already know that T and Q are parallel and Q and R, right? Line Q is perpendicular with line U and is perpendicular with line S, right? Because if that one is perpendicular right here, that means that all the angles that are going to be formed right here are right angles, right? And U and line U and line S are parallel to each other. Okay. A, B, C, and D are distinct lines in the same plane. For each combination of relations to how A and C relate. So this one is telling me that. Let's draw a diagram so you can see it, that A is perpendicular to B. A, B. And that C is also perpendicular to B. So that means that A is parallel to C. The next one, A is perpendicular to B. B is perpendicular to B. C is parallel to B, is parallel to B, so this is line C. So A and C are perpendicular lines, so that means that A is perpendicular to C. And that's it for this lesson. May the force be with you.